I'm going to put Section 2 of Unit 3 as a separate program, but again, we're going to be covering this on the same day. So, Venn diagrams and subsets. We'll take a look at Venn diagrams, the complement of a set, subsets of a set, proper subsets, and counting subsets. Now, what is a Venn diagram? Well, in set theory, we think of the universe of discourse, that is, everything that's going to be included in the set. This is called the universal set and is designated with the letter capital U. Now, John Venn, who lived in this time, was the one associated with these types of diagrams, but actually Euler, before him, used something very similar, so they perhaps could have been called Euler diagrams, but Euler is mentioned so much already that let's give John here a little bit of credit. So there is what we call today the typical Venn diagram, and we want you to include this, of course, in your notes. We have a rectangle. We have a circle within the rectangle, which will designate set A, which is a portion of the universe. Now, we should also mention, as we continue, and we can add it actually to the same picture, and that is a new vocabulary word here, the complement of, and we use the symbol, if we're dealing here with set A, then the complement of set A, which is the capital letter A with kind of like a little prime symbol. That's not an exponent of 1. It's a little thicker, but we're going to just, when we write it, instead of going A to the first, which would be like that, this is going to be A, where we kind of, make that prime symbol a little bit slanted here. So this would be an exponent. This is the prime symbol, which refers to A complement. This is how we would like you to call it, A complement. Now, what is A complement? Well, by definition, if elements of set A, well, let's do the universe first. 1, 2, 3, 4, 5. Now, within set A, we had 1, 2, 3 were the members of set A. Well, those members of the universe not in set A, that would be the complement of A. And what would be the complement of A? Well, it would be 4 and 5. So here's what set A would be as part of the universal set, which is 1, 2, 3, 4, 5. And then 1, 2, 3 are A, so the complement of A would be those members of the universe not in A, and that would be 4, 5. Again, some important notes as we build vocabulary still and go on to later set operations where it gets a little more challenging. Now, here's how it's written, by the way. For any set A within the universal set U, the complement of A is written A complement. Is the set of all elements of the universe that are not elements of A. We just illustrated that. So A complement, put in set builder notation. X is such that X are elements of the universe, and X are not elements of A. Again, put this in your notes. Now, we're going to define what a subset is. A subset of an A, we would indicate this by, in a Venn diagram, putting it within the subset. So A is a subset of B. So if B had elements 1, 2, 3, A as a subset would have elements 1, let's say, and 2 in there. Now, there's many examples. We're only showing you this one using these. And of course, the universe might have 1, 2, 3, 4, 5. Now, how do we write the symbol for subsets? Well, the symbol for subset is sort of elongated C with a line underneath it. This symbol is read as a subset. So, building vocabulary, things for your notes. Now, for our first example in our PowerPoint slides, number 1, number A, we want to know, do we put is a subset or is not a subset to make this true? So here we have the elements A, B, C. Here we have the elements A, C, D. So is this a subset? And the answer is no. Now, 1, 2, 3, 4. 1, 2, 3, 4. Now, we haven't defined this yet, but now we're telling you that every set has a subset that is a copy of itself. So every set is a subset of itself. So here we would put this symbol. So again, you're building vocabulary and you're asked to know the protocol, the rationale for doing it. And there they are. Now here they're talking about set equality again. Suppose that A and B are sets, and A equals B. Well, B then is a subset of A, and A is a subset of B. So what we've just said holds true, and there is the rationale for it. Now, in symbols, this is written as we go into what is called a proper subset. And we have to define what a proper subset is. And let's just give you some illustration of this for repetition's sake. We said this is the symbol for subset. Well, a modification of that symbol is this, without the line underneath it. this elongated C, in a sense, as we see here, indicates a proper subset. Now, what's the difference? Well, in order to be a proper subset, the subset must have fewer than one element of the cardinality of the full set. So if the number of subsets, which we will be describing, let's say is 16, and that would be the number of possible subsets a set could have, then in order to be a proper subset, it would have to have at least one less. So that would be 15. Alright, so again, let's look at this and move on. So describing this, we say set A is a proper subset of B, and it's described here. A is a subset of B, but A does not equal B. That is, it has fewer members or fewer elements than B. This is the definition of a proper subset. And the symbol is this. Alright, let's see what we're going to put here to make example 2 correct. Get our pen ready here. We want to hide that for a moment here. Alright, let's go on here. My pen, there we go. So ABC, ABCD. Now, here we could use both symbols. Say subset and a proper subset. So this would be both. Now, 1, 2, 3, 4, 1, 2, 3, 4. Every set is a subset of itself, but this would not be a proper subset because it has the same number of elements. These would be equal also, but this would not be equal. Okay, that was sort of an easy one. There we go. Now, how many subsets could a set have? Well, we could do a counting tree where a subset for AB, let's say, would have both members, could have one member, or the other member, or another definition is that every subset, one of them would be an empty set. Okay? So, how many sets then? How many subsets if there are two elements? And the answer is 4. Now, do we have a formula that would help us remember how many subsets if there are two elements? And the answer is yes. And that formula is, it's going to be 2 to the number of elements in a set. There are two elements, and this is its cardinality here. There are 2. 2 to the nth power, in this case, would be 2 to the second, which would give you 4. And that's what we have. And that's the rule. And we'll repeat that too as we go along. And there it is. Now, how about the formula for a proper subset? Well, as we mentioned before, and repetition is good, this is the number of proper subsets. Well, the number of subsets, and then to get proper subsets, we have to have one less. So there's the formula for proper subsets. Subsets and proper subsets. And again, the symbol for subsets and symbol for proper subsets. Okay. Again, vocabulary and building background. Now, find the number of subsets and the number of proper subsets. Well, we have 1, 2, 3, 4, 5. So using our formula, and this is example 3, be sure to write that in your booklet, it would be 2 to the nth power, which is 2 to the 5th power, which is 32. And 2 to the nth minus 1 is 2 to the 5th minus 1, which is 32 minus 1, which is 31. Ah, nice. Again, we're using the math, and that you should have this written up as part of your notes. These could all be quiz questions. And there it is. All right, that was a short lesson. We're now going into the textbook, finding complements. Now again, this is written up, so all you have to do is write the answers, but we do want you to show the work of how you got the answer. So let's take a look at number 1 here. This is our universe. This is set A, which is a subset, M I should say, and this is set N, which is a subset. But we want to find, for letter A here, the complement of M. Now, how do we do that? Well, a suggestion would be you eliminate the elements of M from our universe. So we want to eliminate A. We want to eliminate B. We want to eliminate E. And we want to eliminate F. So what are we left with? A C, a D, a G, and an H. And that's a method for doing it. Now for B, we want the complement of N. And I should slant that a little bit more here. Now I'm going to use my eraser and then do the same thing. Now another method for doing it is like put a circle around it. So B, eliminate B, D, E, G, H. So what is left now? A, C, and F. So not too hard, as long as you understand the mechanics of how it works. All right, example 2. Which symbol do we put to make it true? Again, this is written up in your book, so all you need to do is write the answers in. 3, 4, 5, 6. 3, 4, 5, 6. So this is a subset. For B, 1, 2, 6, no 1. So this is not. 5, 6, 7, 8, 5, 6, 7, 8. This is a subset. Remember, a subset is a subset of every set. There you go. And there they are. Now here we are asked to determine, do we use proper subset, subset, or both could be used. So 5, 6, 7, 5, 6, 7. Well, there's fewer here, so it is a subset, and it's also a proper subset. One fewer member. So both. ABC, ABC, we can only use this one. Knowing the rules and then applying. Alright, now here they're asking us to find all possible subsets. How many would we need here? Well, it'd be 2 to the second, so 4. How many would we need here? This would be 2 to the third, which would be 8. So I could list them, but here they are. So you want to take a moment, pause this, and list these as answers. Now remember, an empty subset is included in every set. Find the number of subsets and proper subsets. Well, here this is going to be 2 to the 1, 2, 3, 4, 5. This would be 2 to the 5th, 32. Proper subset, 31. This is 1, 2, 3, 4, 5, 6, 7, 8. I believe, and I have this written up already here, this is going to be 256. Wow! So the proper subset would be 255. And we can see that here. Again, you want to know the protocol, the method of operation, the strategy for getting the answer, and the formulas. Write these down. Again, you can use your notes. Now, you want to study your notes as well. And this will wind up this lesson. Again, since it's a combined, we're not going to be doing these in class. You have your homework, and as we move along.